All right, so in the second part of this lecture, let's continue on with our second option on what we can do with raw data hazard, right? Because we are waiting for the new data inside the pipeline, right? Our second option is whenever the data becomes available, I'll forward them. So let me ask you this question, right? Let me ask you this question. If we go back to this diagram, when does the value R0 becomes available? What cycle has the correct version of R0 right here? What cycle? Can someone tell me what cycle is that?
Cycle 5.
Cycle 3, actually, because I can take it from the multiply right here, right? That is basically R1 multiplied by R2, right? And that's my R0. That's the same thing, R0 right here, right? I can take whatever is generated from that wire, from that output. That's the correct value that I want to write, right? Cycle 5 is a safe method. If I want to be more aggressive, right? The register file here is still has the old version. But the signal right here, the signal here has the correct value. So let me ask you this. If R0 becomes available in cycle 3, right out of the ALU, right? Can I do something with that?
Yeah.
Yes, right? I'll just feed it to the next instruction, say, hey, that's the updated value, take it, right? So that's what I do. That's data forwarding, right? So when will R0 becomes available? It can be right out of the ALU. If the data hazard doesn't happen back to back, it can be from the pipeline register, right? The thing is, we can use this value instead of waiting until you finish the write back. The answer to this question is yes, we can just forward them, right? The key question is how. The solution is called data forwarding. Sometimes we call this data bypassing. Okay, sometimes we call this data bypassing, depending on the textbook that you're reading. Most of the textbook that I've seen so far is called data forwarding. I think older textbook might call it data bypassing. But here is data forwarding, right? So when the distance is 1, if I have A and B, and then A need to produce R0 for B, here's what I can do. I can say, hey, this is a wire, right? I want to do the multiply, yeah, right? Multiply, right, to R0, and the second multiply need R0. This is instruction A, this is instruction B. So I know that this is my new, right, new R0. I know that this is my new R0. So what can I do? How do I connect this wire? How do I connect this wiring so that I still have the correct input? I can take it from here, right? Here. And that becomes my input, right? So let me clean up the slides a little bit and use the example when distance is 1, right? The same example, I just want to redraw A and B. This is my, at this point, right? At this point, this is my new R0. B need R0, right? So what I can do is I can connect this wire, right? I connect it here. I connect it and feed it so that the decoder can pick the correct select signal. So instead of selecting from the register file, it select whatever inputs coming from this wire, right? This wire. This wire. We call this a forward path. right? So in this case, I have the new R0 as an input to my adder. Now, in the next cycle, can I move A to memory? In the next cycle. So let's say right now over here is cycle N. In cycle N plus 1, can I move A to memory?
Maybe.
I can move A here. How about B? Can I move B to execute? Does it have a correct R0 as a possible input here somewhere? The answer is yes. It's right here, right? Right here. So I can move B to here. I don't have to stall anymore. Life is perfect. B can move on, right? So that's when instruction is like dependency happen back to back and the distance is 1. How about when the distance is 2? Over here, right? Let's say I have instruction A, which is multiply R0 multiplied by R1 right into R2. Instruction B has nothing to do with the instruction A. 3 plus R4 right into R5. And then instruction C needs R2. Right? So the dependency happen here. I generate R2. It needs by instruction C. So when instruction C is in decode, right? Instruction B would be here. Instruction A would be here, right? That's when data dependency happen. And as you can see, the distance is 2. Now, let me ask you this question. I have 3 possible points here, here, and here, right? Point number 1, point number 2, and point number 3. Which point from those 3 possible connections will have my correct R2? Which one? Number 1, number 2, or number 3? So let me dive deeper in here, right? I'm doing execute for instruction B. So point number one would have what data? It should have R3 plus R4, right? Because it's basically doing R3 plus R4 in execute right now. Point number 2 will be for instruction A. So in this case, it's going to be R0 multiplied by R1. And this is basically junk, some data that we haven't really run yet, right? So which one has the correct version of R2? I think I got disconnected. When did I get disconnected? My bad. I'm sorry.
Number 2.
Number 2, yes. Number 2 is the correct point, right? So you take it from here, feed it here, right? But again, because when we add wire, it's gonna be there. So that's also another wiring from here to here. Both of this, right? Both of this, we call this the forward part. We call both of this a forward path. And, right, and as you can guess, over here, the decoder has to select, right, has to select the correct input, whether it's going to be this one or this one. The decoder would have to decide, hey, the dependency happened because A produced the data for C, so the decoder has to make sure it pick this option and not this option, and also not from here, right? So that's the job of the decoder, to figure out the correct input that goes into my ALU. All right, so that's when distance is 2. Now let's say what happened if the distance is 3, right? I have A in here, B here, C, and D. Let's say this generate R0 and D need R0. Again, we can go with the same logic, right? You have 3 different points for my data, right? Point 1, point 2, point 3. The correct version of R0 is now available, right, in point number 3. So it can be forwarded from here into here. And again, it's a job of the decoder, right, to figure out which of this wiring, right, that I have to forward in order to make sure that I have the correct signal. So this is called data forwarding, right? And I show you one version of data forwarding where I take the output right away from here, right, and feed it into the decode stage, Another alternative design, I can also feed it to this stage as well. I just move because I know that the data is already available, so I move it right into the ALU. That's also possible. Basically, it's just wiring and also timing. You have to time it correctly, right? Now that we talk about the example, let's talk about the analysis a little bit, right? Because when you look at different type of instruction, compute, load, store, branch, jump, and jump based on register. The thing is, I will have my results. So whenever I say produce here, I have the result. Exclamation mark. And whenever I said use, I mean I need the new version of the data, right? So for most cases, if I have data dependency, I can always forward the data. Right? What's the one case where I have to start the pipeline? The only one case is if I have a back-to-back load. If I have a back-to-back load, which is basically right here, and we're gonna skip this for now. We'll talk about this when we talk about branch prediction. But over here, the case where pipeline stall is actually just when you have load and load again, a load and followed by a load. So a back-to-back load is when you have to stall if you have data dependency, right? And that's a trade-off, right? For data forwarding. The thing is, benefit is clear, right? The performance is much higher. You don't have to stall anymore. The downside, if you do the extra credit for lab 2, you will realize that to get it correctly, it can be quite complex, right? It's not too complex, right? This is basically, let me tell you this. This is like a lab where we will give this to undergraduate students and they can finish it in 2 weeks. But it's going to be quite a complex 2 weeks to get it correctly, right? The reason why I also released this lab for you guys is because, I mean, the computer engineering here in Thailand, you never get to do these things. So we have to kind of re-educate everyone here because we are in a really, really bad place about our architecture community, and most of the undergrad doesn't know how to implement a processor. But it's complex. So consider what if you have to design data forwarding for 30 stages pipeline, right? And also we haven't talked about branches, right? We have not talked about branches. So let me pause here and introduce the next thing that we have to talk about, which is control dependence, right? Control dependence is something like this. If I have an if else or for loop, right? If I have an if else or for loop, again, if you look at the pipeline, you have fetch, decode, execute, memory, and write back, right? when do I know what is the next instruction that I'm gonna fetch? What time, at what stage do I have to know the address of the instruction I want to fetch? So let me repeat the question. Is it fetch, decode, execute, memory, and write back? Again, repeat the question in Thai, right? คือถ้าผมต้องการจะรันบรรทัดต่อไปอะไอสเตจไหนในเนี้ย fetch, decode, execute, memory, write back มันจะต้องรู้แล้วว่าบรรทัดต่อไปเนี่ยคือ address อะไรสเตจไหนครับ
decode ไหมครับ
ไม่ใช่ decode จริงๆต้องก่อนนั้นอีก fetch ถ้าผมไม่รู้ว่า address ที่ผมจะ fetch อะคืออะไร ก็คือบรรทัดต่อไปมันต้องมี address ใช่ไหมแต่ผมเจอ if else อะคือแบบอะผมจะรู้ได้ไงว่าผมต้อง fetch อะไรนี่หรอกใช่ไหมครับ ผมต้องไปบรรทัดต่อไปหรือเปล่าหรือผมต้องกระโดดไปที่อื่นใช่ไหมครับ เพราะฉะนั้น fetch เนี่ยก็จะกลายเป็นตัวปัญหาเพราะผมไม่รู้ว่าต้อง fetch อะไรนะครับ และผมจะไม่รู้จนกว่าอาจจะ execute หรือ decode อาจจะบอกได้ว่าอันนี้เป็น branch instruction หรือเปล่า ถ้าเป็น branch instruction เราก็ fetch ได้นะครับ so that's the problem you have this control dependence you don't even know what is my next line until I decode until I figure out what that instruction is right and until I figure out what that instruction is I cannot fetch right I cannot fetch so we need to talk about it we now need to talk about it because we need to handle branches let's do a quick break. We'll resume at 11:15 and we'll come back and talk about branches. So that is because right now it's a big switch in the topic, right? So I want to make sure we have this break again from pipelining to data forwarding now to branch prediction, right? So I'll stop the video now so that we have the second part ready and